Okay. Yeah. Good morning, everyone, and thank you very much for everyone to come to attend. Yeah, we have close to 50 people in person here, and we are hitting 70 online. So, and we should easily get to 200 people to view this very important and very exciting seminar. So I would just give a quick introduction. Yeah. So how we came to meet Brian, yeah, and the University of Wisconsin Madison. So um, was something that Richard Gordon, yeah, which is also here, keep telling me this is an amazing university in Madison, and I say, where the hell is Madison? Where the hell is Wisconsin? Yeah, and then we went and we organized a visit that Brian came to see us in the Biomedical Research Medical Institute. Yeah, and he came with a very senior team, including the chief scientific officer of Illumina. And then I asked the people at Illumina, what you have to do in Wisconsin? And they come to me, you don't know that in Wisconsin Madison, they have the best enzyme production facilities in the world? And I say, don't? And I say, yes, we produce all our enzymes there. And then I talk to Thermo Fisher, they say, we also produce all our enzymes there. And then Promega and many big companies, they centralize a lot of the enzyme productions and part of that in one city in the US. Yeah. And then we went to say, but why that? Because then once you start understanding, they have what most probably is the strongest biochemist department in the world. Yeah. I don't want to, I hope I'm not exaggerating. I'm quite famous for exaggerate, Brian. Yeah. And then we go visit, yeah, and just blow our mind. Just blow our mind about not only the facilities, the campus is absolute beautiful. Yeah, they are a university city like Stellenbosch. Yeah, and the infrastructure that they have is just exceptional. The equipment and the level of the scientists, and that was kind of an unknown secret to us, which Richard have identified. I went to visit. And then I went and talked to Vin de Villas when he was director and say, you have to go there. And then when they went to the US for Madik Zella, a prize for the Templeton, they took a whole delegation from the university and they were very impressed. Yeah. And since then, we started a big program with them. So Brian also came visit a few times and then realized that Stellenbosch is also a very beautiful place and doesn't freeze in winter like Madison. Yeah. And he started working with us. Now he's mentoring many of our African staff fellows. We have some in the rooms. Can you put your hands up if you are working with Brian? Yeah. Yeah. He's also helping Fluorobiotech startup to develop new enzymes. And we are very excited that he has been awarded a STIAS fellowship. So he will be here with us for 4 or 5 months, yeah, in that. So what we're gonna see, he's gonna talk beyond the lab where science meets industry, innovation, and impact. And Brian Fox has been the chair, the head of the department of the biochemist department for over a decade. That's right, yeah. And the knowledge that he have is really fantastic. But another thing that you're gonna notice, by coincidence, both me and we came with the same shirts today. When I was visiting him, we went for a walk in the forest, his son and I. And then in the way back, yeah, we saw this place called Forever Town, yeah, and which Brian, despite living for decades there, has never been, because it's a very famous sculpture that have many sculptures inside in Madison. And when we went to this place, it's completely blow our mind. These guys were crazy. Yeah, so they were building a time machine. Yeah, that they could go back on time and get the aliens here. And then we met the daughter of the of the founder of that, and she really believed on that. We were quite we are just so shocked. And then by coincidence, both he and I came with the same shirt today. So it's a great pleasure to welcome Brian, yeah, which will be here. He is going today back to Madison, so he accepted to give a very special seminar, but he's working with us and he will highlight that. So thank you, Brian. We are very welcome.
Well, thank you, Tulio, for allowing me to talk to you. Thank you, everybody that I've interacted with here. And a wonderful trip so far. I'm looking forward to come back, and we'll see how long this can go. Ele, thank you for the title. It's always good to have somebody help direct you and move you forward. And so I greatly appreciate that. I will try to embellish around these themes as I talk. And one of this thing, I mean, this is a time travel machine. It goes backward and forward through time. I guess we're connected somehow. Shall we proceed? I haven't had the chance really to do this kind of a thing. Where did I come from? The standard intro for graduate students, young career people. So I thought I should give you a little taste of that. I come from a place, Boulder, Colorado. It's in the center of the U.S. I'll show you a map in a second, but I grew up in a modest-sized town. I mean, maybe a little smaller than Stellenbosch when I lived there, but dominated by the University of Colorado, which was at the time a very prominent engineering school. Had no life sciences to speak of. That changed when Tom Cech, who was a professor there, won the Nobel Prize, and suddenly the biotech industry in Colorado and Boulder particularly just exploded. So I went to high school right there. I lived right there, and I looked at the Flatirons Mountains, which are a giant sandstone upscape of rock. And when I came to Stellenbosch for the first time, I just looked around and thought, oh my God, this is almost Boulder, except bigger. The mountains are huge here. And as you can see, we're a little farther away than you guys are to your peaks. So that was just an immediate attraction. And now, I've been really lucky. This is my airline map of the world. I have been a traveler quite a bit. I've been very fortunate to be able to do that over decades when travel was much more permissible maybe than now. I circumvented the globe when I was 22 years old, all the way around the world and back home. I've been to South America. First trip I ever made out of high school was a trip all through South America. I spent, scientifically many trips to Europe and back. And 3 years ago, I made the first trip to Cape Town. That's pretty much the airline ride I fly. That's a Delta flight. It always stays over water. But so that's where I've been. What I would say to everyone, if you have the opportunity to travel, do it, because something seeps into your soul when you do that. Suddenly appreciate the real breadth and the beauty of the way people interact with their world. And inevitably, it becomes part of you and it changes how you think, almost always for the better, in my opinion. Okay, so here's a little more close here now. I grew up in Boulder. I was a K-12 kid. Eventually, I moved to Minnesota. I went to a university called Carleton College. It's a small private school. And then when I graduated, I moved to Minneapolis. I became a postdoc in Pittsburgh, Pennsylvania, and then a faculty member at Madison. just to put on the scale, the geographical scale, the distance from Minneapolis to Wisconsin is about here to Mosul Bay. The distance from Denver or Boulder, where I grew up, to Minnesota, that first travel is like Cape Town to Joburg. That gives you a little bit of a dimensionality of what the US is. So here's Madison, Wisconsin. This is my home now. I've lived in Madison longer than I lived anywhere else. We're the home of the Badgers. There's sports badgers always, they have this thing as they evolve. Their chests get bigger and their arms kind of begin to puff like this. I've seen it happen to gophers and badgers and wildcats, and that's evolution there. There's a North American badger. Now that's a little guy compared to what I learned the other day, honey badgers, which maybe bite you at the waist high. These guys would go after your calf or your ankle, but they're the same thing. They're never going to let go. So we're supposedly a tenacious bunch in Wisconsin. Now that's my home. There's the airport where you're going to fly into when you come visit us. And I'll meet you as you come down the escalator. I'll bring you to your hotel. Yeah. I live right there, and I work about there. That's everything there about my locality is in about an 8-mile radius. It's a small, compact town. We're on an isthmus between two lakes. This lake is 30 miles around. This lake is about 13 miles around. At the deepest point, they're about 80 feet deep. They're cold, clear water. They have a lot of fish in them. As you can see, there's freshwater algae growing there. I don't know what we're going to do with that. So part of my goal is to let you know what UW-Madison is and what kind of a research environment we provide, and then provide some thoughts about that I've experienced over my career of interacting with industry, which is an incredibly enriching experience for people. And at the end, I want to present to you the outline of a formal memorandum of understanding between UW-Madison and Stellenbosch. And I'm really very honored to be essentially the person coming and delivering this to you. And I'm very interested to hear your thoughts on where potential partnerships could arise. So we're a comprehensive university. We have everything: a medical school, a vet school, a law school, biological sciences, physical sciences, education school. We have been in the top 5 in the US for over 50 years based on the criterion of research expenditures. 2025, we were 1.9 billion. That comes from the initiative of the faculty and the hard work of the students and the postdocs to generate grants from the federal government, from philanthropy, from state agencies. We have about 40,000 undergraduates. We're a 4-year degree to the bachelor. We have about 11,000 PhD students in Madison enrolled now. 33% of them are international. So we may be way far away from the coast in the center of the country, but we do have people coming from all over the world to our university. There are about 2,400 faculty and around 25,000, 26,000 staff that run all aspects of our university. I thought you'd be interested to know this is one. UW-Madison is the #1 university in the United States for Peace Corps volunteers that join the US Peace Corps and then fan out all over the world. We're the #1. We've been that for 30 or 40 years. Part of the kind of commitment and interest that we have. Another one is just, this has come, some people like to hear about this, but UW-Madison has among its alumni, which is a very, very large group, more Fortune 500 CEOs than any other university in the world. And these are little facts, but we do things, and we like to be involved, and we like to push the envelope. Now, I'm going to give this thoughts to you about education, and in black, the first three, these are my viewpoints on what education means. Every one of us is on a lifelong path, whether you want to be on it or not. I'm sorry. The problems arise, you got to deal with it. Those paths, those choices always emerge. And the value of a good education is you can respond effectively to these challenges. You can do it with a sense of understanding and awareness that, I mean, it makes your life better. It makes other people's life better because you include them in your thinking. So our university has had a change in leadership recently. I view that as a very positive thing, and the new leaders coming in have expressed a desire to have a 5-year plan, a strategic plan to get somewhere in 5 years to move our university into a position that sets us up for excellence for the next decade or more. And this is one thing I want to find out. Where are the partnerships? Where could they be in this dynamic world? So our experience is we want to deliver an unrivaled educational experience for students. We want to prepare for their future. We want to be thinking now, what is the world like that we're moving toward? And what can we do to help people be prepared? All universities, we want to discover, we want to create, we want to innovate. We are a university that really likes to convene, discuss, and collaborate. We're probably in the United States one of the most strong universities for a faculty shared governance in the decision-making process. And we want to be excellent. People want to be excellent, right? It's something to be proud of. So this is a little brag bit for me. I was the chair of the Department of Biochemistry for 10 and a half years, like Tulio had mentioned. I think it's a really good department. Whether it's the best in the world's a big place, but we want to be in there. These are the kind of things that I was interested in pushing and supporting from my faculty students. A lot of it is around structural biology. So NMR FAM, this is the biggest publicly available solid state NMR magnet in the world now. International activities, virtual reality, a room where you can go in and put on goggles and be inside of a protein structure if you like, move it around. Cryo-EM is a big investment. Cryo-EM, we started this agreement a couple years ago. This is I guess we're getting to the point of refining it sufficiently and really finalizing it. Technology development, unique ways to recover metals from toxic environments, maybe even with value to recover metals that are going to be useful in industry. Environmental monitoring, quick new technologies, mentorship programs, all of that is part of a department that I built that I'm incredibly proud of the people who did it. I didn't do it. I put the environment for them. Say, go do that. I empower you to do that. That's the kind of leader you guys all want to be. Empower your people to succeed. So I did want to mention a couple of things that we have that I think are unique in the world. One is we created a cryo-EM research center. This center can do both solid state and cryotomography. Solid state or single particle cryo-EM is in a way like crystallography on proteins that you can't crystallize. Small molecule, individual entities. My vision was cryotomography is where the world is going. This is the 3D structure of an entire organelle. It's the 3D structure of a human cell with the RSV virus attaching to it, and later in the stage, penetrating the membrane, the whole deal. This is where the world is going. We can do that because we can collect the data. We are getting data scientists like some that are here that can handle this data. And we have people who are identifying biological problems that push us farther and farther forward. Elizabeth Wright is faculty member in our department who runs two cryo-EM centers. Both of these are collaborative centers. They're always looking for partners to come in and work with. We have a beautiful set of instruments that we've obtained over time. This is pretty much your Thermo Fisher portfolio of high-end stuff. We know how to operate it as a service facility. We also know how to staff it, and because instruments don't run themselves. They need people, and they need people to be trained. That's where opportunity for you all comes. So I know maybe some of you really do know a lot about cryo-EM, have solved structures, but let me give you, just if I could briefly, at the start, and maybe I'm actually mentioning to data scientists what one of the problems here is. So electron microscopy works by having a protein, and you embed it on a surface. This is, in this case, a gold film. And the protein is in ice. So it's an approximation of a biologically relevant state. But this is what it looks like. There's a lot of signal from ice. The ice gets thicker, the electron beam has a harder time going through, and every once in a while, there's some kind of anomaly in this background, in overwhelming background signal. The computational problem for taking this data is to figure out what of these anomalies are real, and then go collect what are called class averages. So in that ice, there are molecules that are in all different orientations. You collect hundreds of thousands of those images, and then the mathematical effort is take all those orientations, which are all everything, and use a computer to align them. And you keep aligning more and more, and sometimes you get image that looks like this, another might have a blob sticking out like that. You sort all these out computationally. You keep building more and more representatives into your model. Your resolution gets better and better and better. And eventually you come up with, in this case, here's an example of a 2D class. All of these classes, you work for a while. Now I don't have an image to show you of a final structure yet, but what I want to say is collaborations go a long way. You find a great biologist with a great problem. You find a great computational biologist. Penny would be an example of a person with a great biological problem from WITS. Grant is now a biochemistry professor who's a computational biologist and worked through the software needed to manipulate this data into structures. Roma is the graduate student that's collecting the cryo-EM data. And Tandeka here works with Penny, she's a senior medical scientist. She made the samples that we work on. I would like to say, if I have collaborations and we have people come to Madison, we like to do fun things. We like to do stuff that maybe you didn't go. We might go to the Forevertron and travel. Here's Tandeka, who's never, actually, I don't think she ever saw snow before, let alone a lake that had 2 feet thick of ice on it. We took her out on the lake and I gave her my ice fishing drill and told her to drill through the ice. She never did that before. You come to Madison, we'll figure out something you could do. So this is a bit of what I do, and just a very high overview of what I want to do as part of the STS work here. I've been an experimental biologist. I've been a structural biologist. I'm learning the power of computational biology. A lot of things have happened in the last few years, AlphaFold being one of them. David Baker won the Nobel Prize for this idea that you can computationally determine the structures of proteins. And if you can do that, you can do a lot of other things. You can probe the stability of the protein. You can do in silico mutagenesis. You can do in silico docking of ligands or drugs or other protein binding partners. And that's high end, good. But for the average person, that is very hard because the workflows and the data structures and everything for individual steps are not well aligned, but everything has to be perfect or it doesn't work. So I've been working on ways with some compute. Yeah. Okay. That better? Maybe. Okay, we find out. So I've been working to try to develop software tools that would allow biologists better access to these computational approaches. And this is just an outline of something that we want to work on when I'm here as a STS fellow with some help from people smarter than me. And just basically go from datas, naming structures, developing reaction intermediates, conformational libraries, a Rosetta ligand docking, and then there's a lot more information that needs to be put out, and then a molecular dynamics calculation as a first step to the description of how a protein structure works over time. This one gets us to nanoseconds. We need to work to microseconds, to milliseconds. And then we have a whole view of the dynamic interactions in biology. And so I'm not sure, some of you may have seen these kind of things before. This is the end product. Let me just show you quickly. What happens in molecular dynamics is you have the folded backbone of the protein. You can see it buried there. You might have a ligand bound to it, and you want to understand how molecular motions and charge interactions and steric interactions affect the function. Okay? So in order to do that, we also all understand that biology occurs in water. And we're essentially bags of water walking around with enzymes in it. A very crass way to describe us. But if you want to understand, you've got to have water. And so you have your protein, you build an electronic box, put your protein, your ligand inside, you fill the box with water, and then you figure out what is the charge on the protein, and you add counter ions. The green is chloride and the purple is sodium. So the box has zero charge, because if it doesn't have zero charge, it'll blow up. It'll just eventually repel itself. But you've got the box, and then you let, by the laws of physics and bonding and angles and everything, you let everything relax and move. And you see what happens. And so this is what the crazy mess of the water and all the solvent looks like. It's dynamic. This is, if I strip away the water and we just want to ask the question, what is the interaction of the ligand, the drug, the antibody, put it in your context, what is that interaction with the protein target? If you could click that one, I appreciate that. So what we're really interested in this. This is our particular ligand. It has a pocket here for part of its substrate, and there's a pocket over here for a part of a substrate. We want to understand what are the interactions here that govern the specificity of that interaction. And I think, and a lot of other people in the field believe, you can understand that, you can modify that, and ask what happened. Did it become a better enzyme for a different substrate? Could you engineer it to a new purpose? Could you kill it? Maybe it's something that is involved in cancer and you don't want it to be active. Can you design something that would kill, a drug that would kill? So these are the tools that I think now with our computational ability, we're looking to enable. And there's way more problems here than I can work on. Maybe someone else around will also find something. So I'm going to progress a little away from these sort of research specific things to begin to ask the question of what does it mean to interact with industry? I mentioned I've been very fortunate in my career, 30 some years. I have always had industry sponsored contracts in my lab. And they have been very enriching. They have their unique characteristics, and I like to talk with you, but it comes in the context of an NIH training grant that we've had at UW-Madison for 37 years. I've been the director of that for 16 of it. And what our purpose is to provide cross-disciplinary training, biological, physical, engineering, data sciences. We want a biologist to be able to speak clearly and in understanding way to a data scientist or to an engineer. So we don't allow no jargon. We don't like people who speak with abbreviations. We want you to be clear and sensical to your colleagues who are all super smart, but they don't spend all the time studying the abbreviation manual of your discipline. We really want to get that. Maybe I have to move somewhere. Center. Yeah. Maybe it's that microphone right there. Yeah. Yeah. Okay. Maybe try over here. Is that okay? Be better. Yeah. Yeah. Uh-oh. Okay. I'll go right in the middle. We really emphasize respect for other viewpoints. Because what the answer to a problem, you might never be able to see it. We like to collaborate on complex problems because complexity means you need a lot of different inputs to solve it. We also like to emphasize innovation and tech transfer. This is part because we live at UW-Madison, but it's where a lot of people want to go. And then I heard the phrase yesterday. I really liked this one. This is a learning piece I had. Science for people. Think about what you do, how you can cook that down into the smallest essence that you can say to somebody else. We all get it now. Science for people. That's a motivating, quick thing. So I have a course called the Foundations of Biotechnology. And it's a curriculum entry point for graduate students who entrepreneurship and for commercialization practices. And we started that with just graduate students, but now we've opened it up to anybody at the university who wants to take it. And it's a very simple and it's very quick. It's a 1 semester course. We want people to understand what is intellectual property. What's a patent? What's a trade secret? What's a material transfer? We want people to understand what a confidentiality agreement, because this is one of the differences between academia in general and industry. Industry would like to have some confidentiality or sense that what they're working on, not the whole world needs to know about it. We do product market fit, we do lean startup discussions, we do fundraising, many other topics. And for our students, this is all like a brand new world. A lot of them, it's like, whoa, I never realized that a business product market fit is sort of like the scientific method applied to a technology to see if it's worth commercializing. These are all thinking, new ways to think. So what we do is we have our students form groups. We have them go in and find an unlicensed patent from WARF. I'll tell you a little bit more about WARF is. And we have them use that as the basis for one of their business market fit analyses. How would one create a startup? Maybe it's not a startup, it's just a licensing opportunity. Maybe that comes back, we don't know why the hell WARF patented that anyway. But any of those things is a learning good outcome. Okay? Now, just to mention, this is kind of the approach that I fell into with Tulio around the Africa stars. We presented a bunch of patents from WARF to people to look at and stimulate their thinking. And my hope is over time, we're going to have many, many examples of this where people will take those ideas and run with them as far as they can. All of our trainees have to take this course before they do an industrial internship. And this is just what internship look like for someone in the biotechnology space. You can see it is spread over everything. These are people who are still not in track to do it, but pharma, biotech, education, agri, people fan out into everything. That's okay for us. Take what you learned here, bring it to your new environment. That enriches everybody. So here are my thoughts. A little simple maybe, and it's about working specifically with my colleagues in industry. But you know what? I think this probably applies to any partnership, any collaboration you want to build. Lasting things are built on trust. No trust, it won't last. Need shared goals. Where do we want to get to together? That's super important. Collaboration works the best when the partners are bringing unique strengths. I can do something, you can do something. I can't do what you do, you can't do what I do. That's stronger. It doesn't overlap because inevitably those overlaps, they'll generate tension. You can moderate it, but maybe you plan ahead. The timelines between academia and industry are very different. This is a challenge for us in a way. All of you people seeking a PhD takes time. You know it because you're in it. I know it because I had one myself. I had the issue and I also led it. Industry's timeline is different. They don't have the ability to wait and explore, and it is difficult for them to do that. So that's something you need to know and acknowledge right from the first point of building your relationship. And then these are two quotes that I really like them because this was Marty Rosenberg. He was the chief science officer for Promega. Very distinguished scientist before he joined Promega. And we were interacting at a time in the Protein Structure Initiative about 20 years ago. And Marty first said to me, what he tells his staff at Promega, but I was all ears because I thought, oh boy, I better pay attention to the granting agent. Don't promise what you can't deliver. Don't give false expectations. You can have aspiration. You can run to push the boundary, but you need to temper that a bit because that will break your trust. The other one is do-overs kill you. And that resonated with me. When I was doing high throughput biology, you're doing maybe making 100 clones a week. You don't have time to go back and patch up 3 potatoes that fell off the truck. You're not going to turn the truck around, drive back and pick up 3 potatoes. You just let them fall off the truck and keep driving, because do-overs kill you. Going backward, just, man, you learn it. You learn this in your life. So if I have people who want to work in academia with industry, and this list, Rich, this came from Bill Chekovich and me talking for a long time. Bill's on the industry side. He's the person that Tulio mentioned was the chief science officer at Illumina. He's from my department. We were really good friends for many years. Industry wants people with analytical skills, and they need people that better understand a business practice. We all get it, how academics work. And we get it. We're like working every semester, and then the semester ends and we got 3 weeks of vacation and we got summer vacation. My industry don't work like that. And you got to understand the culture and the timeline. They all want confidentiality. They want to have IP because that's in the end how they protect their ability to make money. They want students who know what they're doing when they get into the lab at some appropriate level. And in our context, and this is from my interns that I'm sending out, these are grad students. We send them out to a company. Industry wants to pay them. They don't want to try to snitch or get free work or anything. They want to pay. They want to treat you like a part of the company that you understand you're supposed to deliver. And one way they help you understand you want to deliver is they give you a paycheck. That's all good for everybody, right? Now, from the academic side, for students, often not this works best in the 3rd or 4th year of a 5 to 6 year PhD degree, because they've passed their prelim exam go on to the doctorate, and they have skill. They have representative skill. What I have observed so many times, this internship is a pivotal point in a student's career. It completely changes their viewpoint. It changes their life in a way that maybe they didn't know, maybe they don't know what they want to do, this, that. Suddenly things become clear because of this experience, and that's really wonderful to see. We at UW-Madison have an issue of how do you fund people. You can't have a student doing an internship for a company where the federal government is paying you to work on something else. That would be absolute no-no. So we have some figuring out to do, how to use private funds, or industry has to pay often. And we don't like students to do an internship on their PhD dissertation because, well, the company wants to own it. And then the company might say, like, you want to publish that chapter? I don't know about that. And that generates attention. So these are all things, they can all be worked out. But if you know before that these might be points, you can get to it. All right, now, why do I even know anything about industry? Because I went to UW-Madison. And this is a picture. Harry Steenbach, professor, he was the chair of biochemistry for maybe 40 years. This is Harry in his lab, and there's milk down in that white dish, and that light is a UV light. Milk from a cow has a form of vitamin D, which is essential for bone health and calcium metabolism, many things, that is not active. It's a pro form of the vitamin. And Professor Steenbach's discovery was that if he shone UV light on milk and then either gave the milk to rats that were a rickets model or even to humans that had rickets, he could cure rickets. because the vitamin D form was then active and they had bone health improved and all of it. Steenbach was an innovative man. He realized this was valuable and he patented it. He hired a lawyer, he got a US patent, went ahead and did it, and he brought it to our university. He said, I have this patent. I think it's going to be valuable. I want to give it to you. 1925. And our university leadership said, basically, I mean, I'm paraphrasing a bit. Oh, no, no, no. We don't get involved in that kind of dirty money. We're academics. We're very pure. So that, like, Professor Steenbach was kind of, let's say, upset or maybe pissed off that he got some friends who were not part of the university. He formed a corporation called WARF. It's a private, not 501(c) foundation. The charter of the foundation is to accept the intellectual property of the university, invest it, seek royalties and licensing fees, and return the proceeds to the university to further the research enterprise. This was what was written, and that was Steenbach's vision, that patent, which sold to Quaker Oats Company in 1920 something, and for $2 million. That became the base, and that was a lot of money at that time. Other things that kind of happened. This is another thing about to learn and think while you're doing research. Sometimes what you think you're going to discover is just not what the most valuable thing. It's just not. Okay, so this is Carl Paul Link. He was a professor in biochemistry. This is his graduate student, Mark Stamen. They were working in the lab one December, and a dairy farmer came, and the dairy farmer brought into the biochemistry department a bale of moldy hay and said, look, I've been feeding my cows this hay. There's got to be a magic point. I've been feeding this moldy hay, and my cows are all bleeding to death. Yeah, so honestly and truly, the first thing the professor said was, maybe you shouldn't feed your cows that hay. All right, well, thank you for that. Thank you, Sherlock. But stuck with it and said, what is going on here? There must be some biochemical reason this is happening. So what turns out is this plant, sweet clover, it's kind of a weed in Wisconsin. It's in prairies all over the place. People may mow their prairie, bale it up. Sweet clover makes a compound, a natural product called coumarin. Coumarin, if that hay gets attacked by a fungus, gets converted by the fungus into another compound called dicoumarol. Dicoumarol is an incredibly powerful anticoagulant. So a cow that ate the moldy hay would have dicoumarol, and cows eat a lot of things. They eat nails, a piece of glass, some pointy rocks, and if they get a cut, they bleed to death, right? Because they ate that stuff with this. The innovation part of these guys is they thought, oh wow, there are a lot of human afflictions that could use an anticoagulant. So they went to WARF and said, we found this thing, we want a patent. And whom got replaced with WARF, and then the last ending part got stuck on, and you've got a compound called warfarin. Warfarin became a human drug to treat various blood disorders. It was one of the most highly prescribed drugs in the world for a very long time. And another variation on coumarin became a very potent rat poison. because the rats died for the same reason the cows were dying. So there were 2 patents that came out of this, diversified a little. Final one, I mean, we're not all ancient old science in Madison. This is James Thompson. He figured out how to isolate stem cells, figured out ways to stabilize them. That became part of the emerging stem cell biology industry. And Jamie's just a wonderful, kind scientist. He was another one of these long line of inventors at UW-Madison. So here's WARF. Again, the purpose of the corporation shall be to promote, encourage, and aid scientific investigation and research at the University of Wisconsin by faculty, staff, alumni, and students thereof, and those associated therein. Let's find a few thereins. Okay? WARF's a $3.3 billion enterprise now. They are both a patenting, but they are also investment. They have about 4,400 patents. They have a legal status as our designated intellectual property manager. So every member of the faculty who does an inventive act is required to report it to WARF. They decide whether it's going to be patentable, potentially marketable, licensable. But they're our agent. And when I become a faculty member, I accept that as part of my terms of employment. And I'm pretty happy with it because they're good to us. The returns come back to the university, plus or minus some change, around 100 million a year. It's a margin of excellence that helps us do things. All the cryo-EM equipment I showed you, that was bought by WARF funds that came to my department. Faculty startups, graduate student fellowships, postdoctoral work, support for the libraries, all part of the gift back from that one idea from Steenbach. It's wonderful. Now I get to the last part, and I really hope that maybe we have a little bit of discussion here. A MOU, Memorandum of Understanding, between UW-Madison and Stellenbosch. And for students or some people who haven't looked at a lot of legal mumbo jumbo and stuff, this is the first part, the preamble, and now therefore, and et cetera, and good people therefore do wish to interact, and da 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 da. This is a formal way to say our institutions are interested in partners. And once we have the overarching umbrella of the MOU calls for 3 areas for us to interact: education, collaborative research and development, and translational science and outreach. I just want to give a little bit of each, and I'll go through this quickly, but if you have thoughts, like even right now, they're jumping out, or later, let Tulio, let Richard, let Ross, let Vim, let anybody know, hey, I was thinking of this. Is this a possibility? Because once the MOU is in place, we want to fill out all these areas. I think so. Education is the first one. I am interested in thinking about, both of our universities are so interested in entrepreneurship and innovation. Maybe there's a way that we have a shared curriculum. We have interactions between people involved in this space. Even at the start, if it's online, I have a course already that can be a vehicle for part of this. So that's one thought. Collaborative research, look, including but not limited to pretty much everything we can think of. Anything you can think of. You guys are a comprehensive university. You got everything going on here. We're a comprehensive university. We got a lot going on. We live in 2 completely different continents, but there's some commonality, and there are things. Let's find them. And then the final one is translational. This is already, I feel like, is the Africa Stars, interacting with you people, interacting with Fluorobiotech and the Launch Lab. This has started. We can have more. So that's my town. There's the, oh yeah, that generates some interest. This is the university students' sailboat fleet. You come to Madison, you can learn to be a sailboat skipper if you want. You can work your way up from the littlest boat to a yacht. They'll take you out there and they'll teach you. There's the swimming dock. My house is right there. Biochemistry is, I'll make sure I get this right. There's our Virology Institute. That's biochemistry. This is biochemistry. This is biochemistry. This is biochemistry. Animal and dairy science, forest and wildlife ecology, microbiology. We're all right next to each other. That's what I have. Thank you so much for listening. Sorry about the feedback. You know, sometimes I just, Annie. Oh. Yeah. So, yeah, you know, thank you for that. Yeah. Overwhelmingly, we now have 10 years of liberal justices trying to hold the fort, hold the line against this. So, I'm very much appreciate the opportunity to talk here.
It's open for questions, discussions, suggestions of collaborations. Yeah. You know, we are never a shy group of people. We normally have hundreds of questions.
Yeah, that's okay. Woo!
Let's get my adjustment. So Brian, that was fantastic. Thank you. And I'm going to start the ball rolling. So you do a lot of private sector collaborations. How do they usually start? Because South Africa in biochemistry and in a lot of the faculties tend not to try and do private sector collaboration because there's a suspicion of that as you alluded to in your talk. So how do they typically start over the years? And is it actively managed? Is it through personal relationships?
Yeah, so every single one that I've had has initiated as a personal interaction. A scientist that was in industry that either contacted me, said, I read your paper, you know, could we just talk? Or you meet them at a meeting. What's been a universal fail is that the office of the strategic engagement or the office of the business guys or the office of this, and I mean, this is like you guys. What happens in those meetings is you have somebody high level from industry who's actually not going to do any work, and somebody high level from the university who doesn't know anything, and they get together and they have a meeting and they probably have lunch and they go, yeah, this is really great. Well, my guy's going to get in touch with your guy and we're really going to do something and this will all be great. And then 3 months later, everybody forgot that, and then this repeats. So I would encourage you to figure out ways that groups of faculty or students that are interested in those interactions set up some way that you can have almost like social meetings. What do we do? What do we do? We just got to meet each other.
That's a perfect answer, because one of the discussions here is that I think a lot of the South African mentality is, well, it's somebody else's job to set up the private sector collaborations. And some of the discussions we had in this room about 2 months ago is, well, it's actually who you know and you connect with where these things start. So you just reinforced. So thank you.
Where's your shared goal? Who do you trust? And you don't know if you trust somebody if you never met them before the 45-page contract shows up on their desk. You need to sit down and say, hey, how are you today? How'd you sleep last night? That starts it, not the other kind of stuff. Yeah, hi.
Before I give Ambi, yeah, let's talk to Ross. We should start next week our bubbles and biotech.
Oh, yeah. I sort of peripherally heard about that. Too bad I'm not here.
Because that's a way that we can continuously bridge that gap between startups, companies, and things. And we can be bubbles like champagne or Cape Classic, or bubbles like
Grapetizer.
water. Yeah, grapetizer. Yeah, it doesn't have to be just alcohol.
So we have a thing too, high-tech happy hour in Madison. It's once a month. It's, you got to make sure that people from both academia and industry come. Like the only people at the bubbles just can't be all you academics. Yeah. 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 Uh-huh. Yeah.
Thank you, Professor. That was absolutely fascinating. Why I found it particularly fascinating, so this is my PhD supervisor, Prof. Milan, and what we've been working on for a long time is trying to develop new bioproducts to replace chemical pesticides. So not much more of the biochemistry, but yeah, we're really excited about what we're doing. We have a lot of the similar problems that you've brought up. So something we often talk about is how do we bridge that gap between academia and industry? And it's something that we've actually struggled with for a long time. In our case, one of the major hurdles, and I would love to hear if you've experienced something like this, is a lot of companies want to invest in our technology, but it seems that the hurdle often is, in our case, is registration of these products. Now, if you're in agriculture, you know, under one of our acts it's very difficult to get new biological products for agriculture registered. What my issue with that is, if let's say a company approaches us and they say, we won't invest into your technology until you obtain your registration, that can take up to 5 years. And for me, that's a wasted 5 years where you could be doing a lot of R&D whilst you're doing the registration. Now, I know from what it sounds like you're far more on the pharmaceutical side, which is an even longer registration process. How do you manage that, the legislation and the regulation behind these sorts of products, while not losing speed and the benefits of continually doing R&D?
Yeah, so that's a really excellent question. And it is truly, I think, a universal challenge wherever you have a product that somehow falls under a regulatory scheme. I can't say I have any magic bullet for that. What do I offer? These are really not, it's not a university thing. It's a governmental issue. Lobbying could help. Boy, what would I do in the meantime if I had such of a product? Is there some so industry, could they fund something that is parallel or that informs a gap that while this regulation occurs? And I think you probably only get there when what's the shared goal? What are the steps to get from A to B? Are there intermediate things that you as an academic lab can do that they would be interested in, but they really don't want to do it? Or they you know, it's companies often, you know, they're very, seem to be very focused on what they need to accomplish, and side things that are important, might be useful to them to know, but it's not going to directly get them to money. In many ways, that's the kind of things that an academic partner can come in and say, maybe it takes 3-4 months, part of a dissertation degree as a postdoc, test that out, do a validation, do a technical de-risking for them as part of the team. I mean, yeah, your regulation. I agree with you. It's a worldwide problem.
I will give you, Ross, but just to answer to you, yeah. So that's the kind of things that you want to engage quite early, yeah, with Innovos, in the same way that the WARF do that, yeah. And because it's just very different world, yeah. One thing that we are trying to do, and just going back to the MOU, yeah, it is to see how we can, but it will help a lot if the academics, they have the basic understanding of intellectual property and contractual and also the different levels of registration that needed. Yeah. So I think that the course that you say would be very good if we could run that a little bit widely more in the university. Launch Lab has some of that. Our African stars, they went to a countdown program. So that is way. The other way, it is also what we did with the Launch Lab, the CERI Bio. Yeah, that we put our foot down, but of course, Fluorobiotech take that quite serious. Yeah. And we ISO accredited the lab. Yeah. In that case, it's 13145. That's for medical device. Our genomics lab is ISO accredited 17025. As people also have regions in the university that they start working under ISO certification, because then it becomes much easier, the registration, because can you see, because it is, then we are thinking about a red certification and so on. Yeah, I think also the bioprocessing is trying to also get as accredited. And that's something that we have to spread more the university, both the knowledge of intellectual property, how to translate that. I personally, I direct an institute. Yeah, I know nothing about contracts. I have a professional contract manager that will deal with that as Brian said, the mumbo jumbo, what is law mumbo jumbo, yeah. And so, but we have to start getting that knowledge and the systems, yeah, strengthened in Stellenbosch. Yeah.
As you rightly said, you need to deal with the Novus very early on. And we engaged with the Novus, and I think we learned the hard way about if we had had a course like that available, it would have given us such a head start. But we went into a Novus going, we don't know enough about IP, and Prof. Milan and I learned the hard way about how to navigate this whole industry. But I think if you have a course in place like that and we develop this sort of collaboration, a lot more people and graduate students that we have at Stellenbosch will then develop their technology and go in with so much more knowledge than what we've had so far.
Just one thought also about, the one thing that would happen at UW-Madison in this space where you've got a product and industry's interested in it, but it's not quite technologically ready. We can go to WARF, and there are two programs WARF has. One is called the Accelerator Program, where they will give you some money. Let's say, last one I had of those was something like 25,000. And it was after meetings with patent advisors and a potential company sponsor, a de-risking project. It was very well defined that you need to do this to see if it's worth it, right? It's essentially a dollop of money to do a go, no go. And sometimes you get the no go, but you got to do it. The other part is just as you were talking, I think I heard a little bit of the adage, do-overs kill you. You guys went into it thinking like, oh yeah, well, we'll learn about patents on the fly. But if you go in that road and then you go down that far and you didn't make the right choice, then you're going to drive the car backwards. That's the do-overs that kill you, right? People get frustrated. People get tired. It takes too long. All of those are manifestations of not being properly prepared for where you're going. And I thank you for the idea that the course, because I think there's a huge opportunity here. We've got two very entrepreneurial spaces. We're similar but not identical. We're both trying to innovate around solving a problem that everybody knows has got a problem. All right, well, let's work on it. Let's work together on it. That's.
I could also just add a little bit there. So I've done a course very similar to what was being spoken about here, and Carl and I, we both got spin outs at the Launch Lab from Stellenbosch. We were both nodding and being like, you absolutely need to do a course like this, because what it comes down to is that partnership that Brian is talking about. Are you partnered with that company, or are they just trying to offload all of the risk? It's not really about the money, it's about the risk. Yeah. They want you to go through the risk of those 5 years, and then easy will kind of sort of lap up any new product that you may have, just like probably 100 other pesticide companies out there. What you want to do is form a partnership with that company, understand what their pain points are so that you're going in the right direction. And that will kind of alleviate this, you you being always a cycle behind, because they're very current. They understand what they need to do to sort of expand, and they will back you if you're partnered with them. But like Brian said, it's a lot of trust. It's a lot of relationship management. For example, someone who's done it very well is Prof. Robbie Pott. He's partnered with industry, and at that specific industry, there's an old professor from Stellenbosch. They understand each other. They understand how the relationship works. You kind of want to get there where there is trust, and you can give time, and you know your partner's going to, when things get tough, they're going to do the right thing and be patient, grow the relationship, because they're not going to tell you what their biggest problem is just off the bat. Yeah.
One of the things, so I'm Richard, I should have said it earlier on, but I was involved quite heavily in funding a few startups, etc. And the one gap that all the courses have, they all cover IP, they all cover tech transfer, MOUs, legal terms, but very few of them include regulatory. And when I started working in the launch lab, and I think WARF probably have an external contractor. So if you're in Ross's position, for example, you know, there's an ISO element, and you don't know anything about regulation in ISO. If you're working in a diagnostic field, most innovators, well, I got a diagnostic, it works, it's 95% effective. Oh, I need a CE mark, and I need to be registered with SAPRA, and they have no idea about this kind of stuff. Regulatory is, I think, is a missing piece in a lot of these programs, and I would strongly advise that we try and get the regulatory as part of it. So in your world, get a regulatory expert involved, advising you on the way through when you can start selling, because most, if you want a government contract, you need some kind of certification, and that you need to know at the very beginning.
Wim, we have some question online, and then we run out of time. But one thing that I want to convince people at the university is similar what we have in the Launch Lab CERI Bio, have lab spaces in the university that's already certified. Yeah, because people will to take a product. We are doing that with diagnostics that can go to SAPRA accreditation coming from an ISO accredited lab is 100 times easier than come from a kind of unaccredited lab. Yeah.
Yeah, thank you very much, Brian. That was wonderful. And thank you very much for the hospitality shown to us in Madison as well. And I can confirm
My pleasure.
that is indeed a beautiful place, and it's a university town, very similar to Stellenbosch, but quite a bit colder in winter.
You have
but
reciprocated.
and it's an excellent university. So as a ex-vice chancellor, I'm very interested in the money that comes back to the university from WARF. So the Wisconsin Alumni Research Foundation. So I want to ask you a little bit more about that. So in Steenbok's case, and as you explained, so the university was not really interested in taking that further, and it was sort of taken outside of the university. Is it the model at Wisconsin that the university doesn't really own any percentage of the companies that are spun out, and that it's all done through WARF, or how does that, or is that a simplistic way of looking at it?
No, that's a very important distinction. State law of Wisconsin forbids the university system from owning intellectual property. And we're a bit of an outlier in that. For example, I was a graduate student in Minnesota. Minnesota, you as a researcher, if you make a discovery, the university patents it, and then you assign the rights to the university. And state law of Minnesota allows that. Wisconsin state law doesn't allow it. So if I have a patent and WARF takes it, I assign the rights to WARF, and they're the owner of the patent. So that is a distinction. It is a bit, UW-Madison, I think, is unique probably among all universities on that aspect.
But one of the questions, because we are discussing a lot here, then if WARF just license, so a lot of time they will create startups.
Yeah, they will do both.
They will do both.
Yeah.
And what's percentage, normally WARF take in a startup?
I don't think I can give you a standard answer to that, because it may be, I'm going to guess that this is a negotiation between the startup, and Wharf.
Yes.
And then that would be individual, each one. This would be a question for pin down Eric on.
Yeah, we can ask Eric about that because that would
I'm pretty sure it's going to be case by case basis. I mean, something is, well, let's see, like, yeah.
Is a negotiation, like you say, but if I remember the conversation correctly, it's no more than 10%. And that's specifically to encourage investors to invest in the company. But I would say I'm under correction. Wharf does have that number and it is outlined. There's a standard agreement that they follow each time, just like the royalty agreement, 3 to 5% on net revenue.
Thank you.
Okay, so let's go to the online question and then and take you to another beautiful place, Brian.
Okay.
Yeah, for lunch.
Okay, so there are two questions online. The first one says, how can early career researchers strategically manage intellectual property confidentiality agreements and publication expectations when working at the interface of academia and industry, especially in cases where their thesis work overlaps with proprietary research?
So, this is an early stage career person who's doing research that is also potentially generating intellectual property. They want to be in that interface space with academia and industry. And they're wondering, how can I walk that road without?
And I think the question is the tension between publishing or not, yeah, or
Okay.
protecting the IP. Yeah.
Okay, so that would be two parts. Do the first part first. Who's your boss? That's the first thing you need to figure out. Who's your boss? Do you work for the university or you work for the company? And if you work for the university, I mean, you know, you may feel like you're an academic and you're a free, unhurtable cat, but you probably have some obligations of employment to your employer. Be best to figure those out, understand them before you start making actions. Because my adage is, do-overs kill you. And if you make a bad problem with your boss and you got to walk it back and start over, that's just not productive. So that's one thing. The part with the industry that you're going to interact with, make sure that you build the trust first before you go on and on. The second part of the question that I think Tulio introduced, and it's a really important one. Early stage investigators. You're in the university, you've got an endpoint goal is you want to become a tenured faculty member, right? That for many of us, that's the endpoint goal. You want to achieve tenure. You have to understand what the expectations of tenure are at your institution. And historically, and at UW-Madison, tenure comes from you got grants, you published papers, and you graduated graduate students with PhD. That's top one. Number two is you did a reasonably good job teaching your class, or you did a really good job. And those are the two factors that get you tenure. Historically, starting a company has never been part of the tenure discussion. About 4 years ago, I wrote what must have been like the 30th iteration of what are we going to do about entrepreneurship at UW-Madison, and I explicitly put that question in front of our leadership. How do you account for the disparity between an institution that is talking full speed ahead about entrepreneurship and business development and something, and has not figured out how to merge that with the expectations of tenure? I expect that's true here too. And so this is a dialogue, and I would really like to see how you guys evolve, how we evolve, because it is going to happen. The pressure to understand that this is part of the way the world is going, the way careers go. It's the pressure's there. We got to respond, and we've got to do it in ways that really benefit the collective. All I can say, I think that's a great question. It's a not answered one, but it's something that we have to think on.
Okay, so I know that we have more questions, but I think that we went over time. Yeah. So what we will do, is try to gather some of the questions and see if we can answer them in the chat for the next seminars. Thank you very much, everyone. It was really great to have you, Brian. Yeah. And thank you for this very inspiring presentation, because very important for us at Stellenbosch. At the moment, we are discussing a lot. We are at the most entrepreneurial university in South Africa, but we want to go much, much, much further. And all that, and this partnership and MOU with Wisconsin Madison is very important. Your time here to help to mentor our African startups are very important for us. Yeah. And really, really to say thank you to all the effort that you are putting in this collaboration. And also to thank Richard Gordon, because he was the one that keeps saying, you have to go there. They are incredible. And he's the one, the really engine that is pushing between our both institutions. So thank you two very much.
This is, yeah.
Yes.
Richard, essential. Thank you so much. You've helped me find my passport when it was in my hotel room. You taught me about swimming in South Africa. Let's see, what else have we done?